All right, thanks everybody for coming to, I think this is the last talk in this room for today, so I'll try to make it quick. Don't want to hold you all too long from the marketplace. But my name is Melvin Hilsman, and our talk is getting a neural network up and running with OpenLab. So a little bit about me. My title's kind of long, so I abbreviated it, and it's OSC Operations Manager with Huawei. For OpenLab, I perform the role of a DevOps lead. Essentially, I work with developers and operators who are part of OpenLab, who work at one of our partners, or who participate, out of their own goodwill in the many open source communities that OpenLab works with. And finally, I like sports. I'm a native Houstonian, so I was kind of disappointed yesterday that the Rockets lost to Golden State Warriors. But if there's a Texas team playing against a Houston team, of course, you know who I'm rooting for. So our agenda today is pretty straightforward. It's just 5 pieces. What is OpenLab? I'm going to basically tell you a bit of background and give you a sense of why for OpenLab, how to access resources. Using OpenLab is pretty easy, so we'll kind of go through some examples of that ease of use. And then we'll look at a simple neural network. Disclaimer here, I'm not a machine learning, AI, deep learning professional. I'm not an expert by any stretch of the imagination. I'm kind of learning a lot of this stuff. But I'm going to try to give you just an idea of what they are if you don't know. And then an example of something through a video walkthrough of what you could do with resources in OpenLab. And then we'll finally round out things with how do you get involved. So what is OpenLab? OpenLab is a community. People, developers and operators who work in open source work in OpenLab as well. And what we want to do as a community is identify various stacks of open source projects, see how well they work together by deploying them, report the results that we obtain from deploying these projects to everyone, and help where we can to make things better. So for the cloud and AI era, just as LAMP came to maturity for the web service and servers and service area, it's kind of what OpenLab wants to do. We want to find, again, the various stacks. So tools and a community of individuals and partners working to uncover those stacks is essentially what OpenLab is. And we had a soft launch in November of 2017 at the Sydney Summit. We called that OpenLab 1.0. And we were really focused on multi and hybrid cloud. So as you see, we just had a logo. We had a logo and a dream at that time, really. You may have seen it, you may not have. I think it was up for like 3 or 4 seconds on the screen. You probably very much missed it. But we did get some contacts from that. And then later we came back to the Vancouver Summit. Myself and Mohammed Nasser from Vexos did one of the keynotes. And we demonstrated Kubernetes and OpenStack working multi-architecture. We had x86 and ARM servers running a stateful application, which we had MySQL, WordPress, and we demonstrated that during Vancouver keynote. And so through that process, we got, like I said, a lot of people involved. We work very closely with the Kubernetes community, very closely with Terraform, Cloud Foundry, a lot of different folks. And then we said, well, kind of where do we go from here? We've made some great progress, got a lot of people involved, kind of got our tentacles in various aspects of the Kubernetes community and others, but kind of what's next, and that's where we got the OpenLab 2.0. And so our focus now is getting more involved with more cloud native projects, AI, which is essentially why I'm here doing this talk, and cloud service aggregation, which is open service broker, and also the operator framework for Kubernetes. So some of the benefits of using OpenLab, as I said, great thing about what we're talking about is if you're a person who wants to use an open source project and you have some difficulty, which many of us have, deploying those individual open source projects or deploying those projects together, there's some, rudimentary stuff you may run into, like, okay, does this project even deploy? If I'm using Kubernetes OpenStack, can I even run, Rook or some other project on top of that? And so with OpenLab, what we're trying to say is, okay, if the community comes together and they say, well, this, it's OpenStack at the bottom, then we do Kubernetes, and then we do Kubeflow on top of that, and then we're trying TensorFlow with Kubeflow. And so does that, just on the basic level, does it deploy? It does, okay, great. So we report that information back, but then we have someone who's trying to use that for their AI, and they try to run some set of tests or whatnot, and it fails. And so what we're able to do is say, well, versus that individual having an issue and trying to go figure out which project that issue is in, as a community together, we can say, okay, well, it's a Kubeflow issue, it's a TensorFlow issue, it's a Kubernetes or OpenStack issue. And then we have the connections and the people who are involved in those communities to go back and kind of use their influence and help resolve the problems. So baseline integration, we're not talking about being the people who are deploying this stuff for you, but just doing the very rudimentary aspects of things to help you remove some of that early on headache. This also helps to facilitate and foster cross-community collaboration, speed up time, the value of open source projects. Like I said, it helps you decide, which projects you should invest in, how long you should invest or work in those particular open source projects as well. And we keep the lights on for you, so OpenLab's available 24/7, anytime, anywhere, to anyone. General workflow is that we find these projects, we get them together, we deploy them, we get all the community hardware, the people, software, all that different stuff, and then we provide that feedback to these different communities in hopes to increase their key metrics, included but not limited to usability, performance, and reliability. So access and resources is pretty simple. We've got a short URL here for you. You go to that short URL, we do everything via GitHub, so you just fill out this form on GitHub. If there's questions there that we have, what we'll do is we'll reach out to you. One of the OpenLab team members will say, hey, you've answered this question, but it wasn't very clear. You need a GPU, but you didn't state that reason why, or if you needed more than one GPU. So we interact with you throughout the request process. We make sure that resources are available. We hand them over to the people or organization that requests the resources. After you're done with your testing, you return the resources back to the pool essentially. And then we got to make sure we publish the results however we agreed that the results would be published. For example, a project that's using CI/CD via OpenLab, they're just simply saying, hey, we have a lot of pull requests, so we go and we pull, reports every single month or however for that particular project to publish some results of how they're using OpenLab. So like I said, it's pretty easy. So 3 key areas. There's probably other stuff that you could do with OpenLab, but 3 things that we really see as OpenLab being useful to folks, and folks have been using it, is CI/CD. So OpenLab can host it for you, and we use Zool CI, which is an OpenStack Foundation confirmed project. But then there's also a non-OpenLab hosted CI/CD requirement. So, and a good example is the Adopt OpenJDK project, which is a very important open source project. They needed some ARM servers, and they weren't able to find them anywhere, for lack of better terms. So what we did was work with one of our partners. We provide them static ARM64 VMs. Those don't, go up and down like something that Zool does, where it just runs a job and then it returns the virtual machine back. But it is limited availability. Also, of course, there's virtual machines you don't need to do CI/CD. You just want some machines to do some testing on. You want some containers. You want, to do some software-defined networking stuff. That's also available. And then what I call in real life IRL, I just want a server. Like, my laptop ain't cutting it. It doesn't have a GPU. I need a server to test out some stuff. Okay, great. Fill out a form. We can help you out. And there's also network devices, wireless stuff. Like, we've got test beds that have these devices sitting out in the open. There's people that's got robots running around inside of these warehouses that you could use. Just a bunch of different stuff. So in those particular 3 areas, CI/CD, virtual machines, and in real life, these are the projects or partners that we've established that help in those areas. So Zool for our CI/CD, cloud providers for virtual stuff, and test beds for physical real life stuff. So again, it's pretty easy. Open issue. If you don't have anything at all. Like you don't have anything, you need some resources, you could start there. But if you've already got resources and you're the type of person where, I just want to deploy something really quickly. Example of a partner is Chameleon Cloud. They have an appliance catalog. And so what's cool about that is you just log in, you click a button, so I want to launch, ARM64 server with OpenStack on it. You can do it that way. So you don't have to deal with a CLI, you don't have to deal with anything other than just click a button and launch some stuff for you and give me the login details. If you're the type of person where you want a little more flexibility, and using the CLI is still kind of like climbing, pardon my little story here, climbing a giant beanstalk with the threat of a giant looming, Jax, Jack beanstalk, whatever. Giant Slayer. So you got CloudLab. It's a GUI. It's not as easy as the appliance catalog, but then it also is not as bare bones as CLI. I'll show you guys that. And then also, of course, you can interact with these individual things via the CLI, which is pretty cool. You can spin up a bunch of resources and use the CLI to get it to send you some information back without having to deal with logging in and stuff. All right, so let's look at CI/CD. So I'm going to try a demo, which is basically me. I have an open source project. I need some CI/CD, and I want to run a job. So I hope this works. All right, I'm going to try to switch to my terminal here. I don't know what that is. I don't need you to mess with my stuff. All right, can y'all see that? Probably not. All right. So what I'm doing here is basically just creating a repo on GitHub. And I hope that works. Yeah, it did. All right, cool. So I've got this repo. As you can see, HTML URL, that's the organization, JIT coding. And then the repo, I don't see it listed there, but it is Denver-demo. All right, so we did that. Nope, don't want to do that again. All right, so I'm cloning it right now locally. Then I switched into its directory. All right, and then in this directory, I'm creating a Zool configuration file. So Zool looks for zool.yaml, zool.d, .zool.yaml, or .zool.d, and it copies that into its configuration so that it knows that it can, it has jobs, it has a project, and all the other components that it needs to understand about that particular project or repo. All right, so we created that. I think we're on 4. All right, so now I'm going to go ahead and create that job. Okay, so it's just a simple no-op. It's just going to write a file to temporary and put hello world in it. All right, so what I did there is basically I just added all that stuff and did my commit and all that. I think we're on 7. All right, so after I did that, I need to install the GitHub app. So we have an OpenLab app, but here's, of course, a demo app. So I need to set this app up on our new repository. All right, so we got that done. I think we're on 8. Yeah. So now I'm going to log into where Zool is set up. This is just a demo Zool. And all right, so that didn't work how I wanted to, but no problem. We'll just do it manually here. So basically what I'm doing is I'm going into the Zool configuration, and what I need to tell Zool is, hey, here's this new project. But this is all done by the OpenLab team. So the stuff I did before, which was, create your repo, add your Zool config, add your job, and then install the GitHub app, that was all what you would do, right? So it's pretty easy, pretty straightforward. Then we add your repo to OpenLab Zool. I think this is right. So basically reconfiguring Zool, say, hey, got this new repo, just refresh stuff so that it's gonna be available to us. And then what we're gonna do after that, once this gets done, okay, I hope that doesn't take too long. That's gonna be bad. All right. So I think we're on, nope. All right, yeah. So what I'm doing here is creating a new branch demo, creating a .trigger file, then I'm going to fork this repo, and then I'm going to do a pull request. All right, let's see if this is done yet. All right, so that's done. Now we should be able to, once we do our pull request, I can see better over here. All right, so there's our nice little pull request. And if we go to the dashboard here, all right, so it hasn't run yet, not sure exactly why, but I did do this earlier, and here's that, essentially here is that, me doing that earlier. And so all I did was set up a set up a project, create a job called a no-op job, which basically just do anything, right? And then I create a pull request, and then before what happens is that the pull request, if we go back to, should be here, you would see basically this inside of your pull request, right? It's like, hey, no op ran, and it was successful. All right, so half okay demo, half working demo there. All right, so that's, okay. I don't know why PowerPoint decided to close. Okay, let's get back to where we were. All right, cool. So creating the, so again, OpenLab being easy to use for your appliances. So basically what you would do is you would have an account, we'd create you an account with Chameleon Cloud, you would go here, there's a number of appliances that they already have set up. You would just simply click on an appliance. Hey, I want to launch that. That's all you do. You would log in with your credentials. And then it would go, and there it is. It started working on launching that for you. And that's pretty much it. You would go in, configure things, what's the name of your instance, source, et cetera, in the actual app catalog, appliance catalog, I'm sorry, it tells you, if necessary, things that you need to add here as well. All right, and that's pretty much it. Like I said, it's not as much as dealing with the CLI, but it's pretty push button, pretty easy. All right, and then the next demo we have is JAX. Like I said, with JAX, what's cool about JAX is you get to go in and you have a little more flexibility. You can create these topologies and you can save them. As you can see, we have a number of topologies that people have created who have used OpenLab. And you can come back and view these, and they're shareable. So you could create that just by hitting this instantiate button right here, right? If you wanted to, however, not use one that's there, like I said, you could use JAX. You just select create a new experiment. Then you go to the topology viewer, you just start dragging and dropping stuff. Like, hey, I want 2 dedicated servers. those are going to be in one site. Then I want to create another site. For whatever reason, I need to test some stuff out. I put a VM in this second site over here. Then I want to go ahead and connect it to this one versus the other one, et cetera, right? And you can also click on these individual things, dedicated to these individual resources, even the links themselves. And there's a number of configuration options you have available. So there's different types of hardware. Some hardware have GPUs, some hardware have a lot of storage. You can do a routable IP, so you only want to be able to access this node, publicly. These nodes are, private behind private IP routing. Also, you can, set up a tarball. So what else is cool about this is that once you've kind of figured out your topology, you can actually create a GitHub repo that has tarball or any other various items in it. And then you could set it up to where you pull down that GitHub repo and then you execute a script or a number of scripts along with your topology and then whatever else you need to do manually. It will provision and deploy stuff as you set forward. So it's pretty, it could, again, it's not as easy as the push button that the appliance catalog gives you, but then you don't have to deal with the CLI of trying to figure out, how do I talk to these individual clouds or individual resources in order to be able to deploy stuff. All right. Let's see here. Let's get back to PowerPoint. Okay. So that's JAX. And then I won't even, this was in case we had some issue, had a video for y'all to kind of walk through all that, but we'll skip that. And in the CLI, I'm not even gonna try to demo it, to be honest with you. It's very intricate, I'll just say that. There's a lot you have to deal with. Because these academia, these test beds were built by scientists and they've got some unique ways of doing stuff. But if you want to be able to do it, hey, it's there for you. All right, so neural networks. Kind of really, OpenLab is really why we're here. I'll kind of touch on neural networks. I'm hoping that y'all know about these, honestly, because, again, I'm not going to get deep into it. But essentially, right, you have CPUs or GPUs. Both are still used. However, deep neural networks and most AI machine learning tasks are parallel problems, right? So parallel computing solutions basically speed things up. So your GPUs are going to be more beneficial to you, but still there are some things that people are doing with AI, machine learning, deep learning, et cetera, that they still do some stuff with CPUs. You just can't do the serial processing, my understanding, with the GPUs, because basically like you would essentially be shutting down the GPU to get it to do anything you would normally need done with a CPU. So it just really doesn't make sense at the end of the day. And really, like I said, it's all about the math. So most of this stuff is floating point math. And like I said, GPUs just excel at floating point operations per second. So it's all about the flops. I don't know if y'all know LeBron James. He's like known as a flopper. And so, over here I kind of got your, Chris Bosh, he's kind of like, hey, he got hit, he's flopping. It's kind of like your CPU, but then LeBron like really goes in and he seriously flops, right? And so that's what, it's all about at the end of the day, floating point operations per second. I think they went on to win a championship that year. So there's many types of neural networks. Me doing research for this talk and just getting more involved in AI and machine learning in general, I did not know there were these many neural networks. There's a lot more that aren't listed there, but I did provide you this really good article I ran across. I put a short URL for it. It's much longer. It's a Medium article. Is actually an institute that really Asimov Institute are the ones who kind of put together the work, but the guy that wrote this article utilized that information to create these charts and stuff. But neural networks it's basically, it boils down to input, hidden. There's an input layer, hidden layer, and then output layer, right? So Input is just simple, like I got a picture of a cat, I got a picture of a dog. I'm going to send it into, my neural network. And then the hidden layer is where all this stuff happens, right? It's where all the computation is taking place. And the output, again, is very simple. Is it a cat? Is it a dog? So in this hidden layer, you have, or in the neural network in general, right, it's all about connections. Everything generally connects to each other. But in that hidden layer, it's about weights and biases and functions that you have running that decide or help the network decide, is this a cat or is this a dog image? And so, this is kind of just an idea of how that happens. If you had a button here, hey, I got a button that just says it's a dog, or a button that says it's a cat, and then the neural network can figure it out on its own. So in OpenLab, like I said, we have GPUs, and one of the key things that you need, as I just told you, is a GPU for machine learning. A lot of people don't have GPUs on their laptops, or if you got one, it's probably old, or it's not really designed to do, machine learning, AI, deep learning stuff. So what I have here is a pretty good example of something that you can run in OpenLab. It uses a library called processing, and as you can see here, it's pretty self-explanatory. The code is up on GitHub. You have to install processing, and you also have to, of course, install the GitHub project. But essentially what you have here is there's this neural network. This guy he set up a neural network where the input, there's 24 neurons. The hidden layers, there's two hidden layers of 16 neurons each, and then there's an output of 4 neurons. And so the reason why you have 24 over here is that these snakes are able to look in 8 directions, and the snake looks for 3 things in each direction. Looks for its distance to the food, which of course is the red dot, the distance to its own body, and then the distance to a wall. So 3 times 8 is 24. And then again, in the hidden layers, the 2 middle layers, there's computation that takes place based on the input. Again, weights, bias, things of that nature are there, all your machine learning, AI, and deep learning stuff. And then at the end is decision making, does it go up, down, left, or right? And so essentially what this demo is demonstrating is that each generation of this snake, there's 2,000 snakes in each generation. So every generation before the mutation happens, which basically is the process of finding, of those 2,000 snakes, which ones kind of made the best choices, right? And then you take those that you decide or you think made the best choices, and then you kind of meld them together, mutate them together, figure out, okay, what changes need to happen to the network in order to make, the next generation better than the previous. So this snake had no idea, again, from the very beginning, what to do. It just had, inputs and just outputs, and then again, of course, the functions and computations that happen in the middle. And over the course of time, it basically took about 14 generations before the snake really started to show some good response. And then at about generation 17, it's got interesting where it basically kind of started figuring out stuff a lot quicker than before, to the point where I think he kind of fast forwards here, you get to about generation 30, and the snake, it's just long. This thing has pretty much figured it out, and he ran a lot of other tests, or a lot of more generations beyond that, and generation 30 seemed to kind of be the sweet spot. So essentially, again, like I said, this is what you can do in OpenLab. You may not have a GPU, or you may not have significant CPU power, RAM, or all the other things that you would need in order to run this neural network. But signing up for resources, you'll be able to make it happen. All right. So I think it's pretty much just about done here. He sped it up. It's at generation 20. What happens also is like, so the snake, you don't want, like, it has this fitness metric, right? So fitness, there's two things. It's basically how long it takes the snake to live, like, before it hits a wall, or hits its own tail, right? Because that's the negative or the dying of the snake, versus its score, which is, how many times it hits its food, right? So at about, as you can see, the best fitness is listed there, the moves that are left. So essentially, if the snake got caught in a loop, right, where it was just moving, up, down, left, right, in circular fashion, then, it would just keep doing that forever. So what he had to do to limit it was the snake started off with a certain number of moves, and then every time it got food, it would get additional moves. So it's kind of like that, in some more rudimentary AI machine learning stuff, it's kind of the reward versus the non-reward aspect of things, right? So as the snake gets rewarded, it gets more moves and it's able to utilize its inputs to make better calculations. But again, at around generation 30, as you can see here, this is the final generation of it running, and it's like, it's going to get really long, and by that time, that's pretty much as efficient as it got. So I'll give y'all the pleasure of seeing how long the snake gets. How long do you think, how much longer do you think it's going to get? People say that AI is going to take over the world. Is the snake going to take over its own world? Nah. It's going to get pretty long. Anyway, I'll stop it because it's going to keep going. But that's pretty good. It's very impressive, like you're saying there, from the point that it's only 24 inputs, 4 outputs, it's a small number of computation, a small amount of computation in the middle. And only 30, and after 30 generations, if again, this thing not knowing how to play this game, not knowing pretty much anything about Snake, probably would beat me on my best day, clearly. All right. So how do you get involved? You could, if you decided to be, a person who just wants to help publish stuff, who wants to work with some of these open source projects, or a number of different things that we haven't even thought about yet with OpenLab that you think would make the project itself great. OpenLab-membership, there's no CLA, I think it's called CLA, yeah, there's no license, like there's nothing to sign or anything like that. Like I said, you can write test cases or you can integrate OpenLab. Maybe you know of an open source project that could use the benefit of CI/CD from someone like OpenLab. And then there's all of our contact information, of course, on the right-hand side there. All right, so here's references to all the things that you saw. Here's the, if you go to the guy's URL here for the YouTube training a neural network to play Snake, you'll see the link for his GitHub, as well as, like I said, you can come sign up for resources at OpenLab and you can replicate that. And it's very easy. There's a lot of examples out there I found that were difficult, but this one is pretty easy if you just want to get your feet wet. And with that, I think we're pretty much done. Hopefully I got you underneath time, and if you have any questions, I can answer them. No? All right, thank you so much.